Guys, so in this video we're looking at one of the questions in our study guide, which is this one over here that says solve the following integral. Now if we look at this integral, we notice that the integrand is actually a trigonometric function and it has a power of 5, which is then an odd number, meaning that it has a odd power. So remember what we said in the previous videos. If you are doing trigonometric integration, right, and the power is odd, meaning that the identity that you use is sine x plus cos squared x is equals to 1, and you can write this as cos squared x is equals to 1 minus sine squared x. So if the power of cos is odd, then you will be using this identity over here. So now, if you look at that, this is cos to the power of 5, meaning that we have to rewrite it such that we have the even part and the odd part. So this is then equals to, let's write it here, so this is cos to the power of 5x dx. Remember what we said in the previous video, that the odd power will always be the power of 1, and then, so this is cos to the x dx, right? That's the odd power, because we will rewrite it. So it will be to the power of 1, and the remaining one will be cos to the power of 4x. Reason being, if you look at back your exponential function, a to the power of 4 times a to the power of 1, because bases are the same, we add the exponent. So this will be a to the power of 5. So here the bases are the same, it's cos cos, this is to the power of 1. So it's cos cos, then we add the exponent. This together, this whole thing will actually give us this part over here. Okay, now let's continue. So we can see that they said that if the power is what? If the power is odd, we have to use this identity here. And when do we use this identity? If we have cos squared x equals to if we have cos squared x. Now here we don't have cos squared x, meaning that we have to rewrite the even part such that it has to the power of 2. So according to our exponential law, a to the power of 4 can be written as a squared squared, because this times this gives us a to the power of 4. So meaning that the even part, this even part, because we want to use this identity over here, can be written as cos squared x squared cos of x dx. Now that we have the cos squared, so therefore we can be able to use this identity over there. So then this is equals to the integral of 1 minus sine squared x squared cos of x dx. So now let's simplify this. Then we know that this will be equal to the integral of, so remember that if we have, for example, x minus a squared, this is the same as x minus a times x minus a. Then you have to multiply x, multiply that, you multiply the bracket. So we'll do that. So meaning that the answer here will be 1 minus 2 sine squared x plus sine to the power of 4x cos of x dx. Okay, now let's continue. Now this will be that. So let's multiply cos inside. So multiply cos by 1 cos, and then multiply cos by negative 2 sine x sine squared x, then we multiply cos by sine to the power of 4x. So let's do that. So this will be equals to the integral of cos of x minus 2. So let's put brackets there, sine squared of x times cos of x plus sine to the power of 4x times cos of x dx. So remember, we can take the integral. We are allowed to take the integral of the individual terms. So meaning we're allowed to write it like this. Integral of cos of x dx minus integral 2 sine squared x times cos of x dx plus integral of sine to the power of 4x cos of x dx. Okay, now let's take out this 2 so that we remain with the, what's this? So that we remain with the trigonometric functions only. So then we have the integral of cos of x dx minus 2 integral of sine squared x times cos x dx integral of sine to the power of 4x cos of x dx. Okay, so now from this point, we then have to look at what formulas can we use for each term. So we know that the first one, we can use this formula over here. Remember, that is on page 2 of our study guide, the standard integral formulas. So that is number 7. Number 7 says if you're integrating f of prime of x times cos of x dx, we'll get sine of f of x plus c, right? Now, these two, if you notice, we have, okay, let's rewrite them like this. I just want you to notice something here. Okay, so let's rewrite them like this. So this is equals to the integral of cos of x dx minus 2 integral of sine x squared times cos of x dx plus integral of sine of x to the power of 4 times cos of x dx. Now from here, you'll notice that actually we can be able to apply one of the formulas in the standard integral table, which says that if you are integrating a function f of x to the power of n times the the derivative of that function, then this is equals to what? This is equals to f of x n plus 1 over n plus 1 plus c. And you can see that here we have a function and we know that the derivative of sine is cos, right? And then our n in this one will be 2. Here we have a function which is f of x, which is, we have f of x, which is sine, and the derivative of that function is what? Is cos. So our n here is what? Our n here is 4. So meaning that we'll use these formulas over here. So let's do that. The first one, we said we're using this. If we look at our f of x here is x, so the derivative of x is 1. So meaning that this, we can use that. So this will be sine of x, right? Minus, now, what is n? We're using this formula over here. Our f of x, let's start with our f of x. Our f of x is sine x. So let's substitute sine of x. Now they say n plus 1. Our n is 2 plus 1 over, let's not forget this 2, guys. That 2 over there, over 2 plus 1. Plus, here, our f of x is sine of x. Our n is 4, so that's 4 plus 1 over 4 plus 1 plus c. So let's simplify that. So this is equals to sine of x minus 2 over 3 sine cube x plus sine to the power of 5x over 5 plus c. Therefore, we then have solved this integral, which is integral of cos power of 5x dx is equals to sine of x minus 2 over 3 sine cube of x plus 1 over 5 sine to the power of 5x plus 6. Okay, so that's how we then solve this particular problem. Thank you. Bye.